Hello again. I'm back with another clock, and the story on this one is I was in a local thrift store when I spot up on a shelf in a corner of the place what looked to be 6 or 8 anniversary clocks. And I go to take a closer look at them and realize that every one of them was a quartz clock, one that's running on batteries, which I really wasn't interested in. And then I spot this one, which is a regular anniversary clock, except it looked to be the smallest one that I'd ever seen. So I got it. I'd worked on miniature anniversary clocks in the past, also known as 400-day clocks, but this looked to be even smaller than that. And as a comparison, I'll show you what I have here. The one that I worked on before was this. It's known as a coach clock. And you can see even this is larger than the one I have here. And both are considerably smaller than a conventional sized anniversary clock, which I have over here. So I started to take a closer look at this one, trying to figure out what brand of clock it is. There's some very small printing on the front. It's very hard to make out, but it says Kern, which I had never heard of before. And when I turn the clock around, the only writing that I can see on the back, it's hard for you to see, but the letters KS. I hadn't seen that before either, and really had no idea what kind of clock this was. And as I began to move it around, what I noticed was on the bottom was written, I don't know if you can see it, at the top it says 1406C and the letters KS 12E model and then .002. And the .002 reminded me of the numbers that I see in my Horolover 400-day clock repair guide book, and that refers to what size suspension spring is required to, that it needs. So I went and looked to see if I could find this in my Horolover book, and I'm going to try to show you the information that I found. The easiest way for me to show this is by hand, so don't mind if the camera gets a little herky-jerky. But the first thing I did was I went to my Horolover 400-day clock repair guide book, and I looked up if I could find KS. And what I found was that there were several of them, and what KS stands for is Kern and Son. And the next thing I looked for was that number 1406E. That refers to the model of the plate, and I found that. That's F. Where's the E? Right, here's the E. So this plate matches the back of this one, and that .002 is really .0023. That refers to the size, the suspension spring size that you need for the pendulum. So I was pleased that I was able to find this clock in this book, and it is from 1958. And the other information on the bottom that said Unit 12E, that refers to the length of the suspension spring. And again, I'll pick this up, but you can see there that it says, where are we? Unit 12E, and I'll show you what that looks like. .12E is right there, and that's giving you the length of the suspension spring from the top block, the fork, and the bottom block, which is what grabs hold of the pendulum. So what I want to do next is move the clock over to my work table and try to show all of the issues that it has. One other thing that I found in this book, which was really quite helpful, and I'll show that as well, they have lists of all of the parts that the clock is made up of. And this particular one is right here. And it pretty much shows every part as well as what the name is. So I should be able to pretty clearly explain exactly what's going on with this one. So let me get it set up. And one thing that I want to clarify first, I had mentioned that the writing underneath the clock said 1406C, and I've been showing 1406E in the book, and the reason for that is the plates are identical, the 1406C and the E. The biggest difference is that the writing, the KS, this one says Kernensohn, Germany, and this one is more detailed, saying, where to go, Kernensohn, Germany, and no or 0 joules unadjusted. And in doing more research on them, they did make some clocks that had no writing on the back of it. So since the plates are both identical, I'm going with what I'm calling 1406E. Anyway, let me get this on my work table and start to show you the problems that it has. Okay, what I found was when I would give the pendulum a turn, it would only go for a couple of minutes before stopping. But during those couple of minutes, the minute hand wasn't moving at all. And normally, the minute hand will move a little bit, even if the clock is not going to run for a very long time. The other issue I discovered was that when I would try to wind it with the key, I couldn't. It just kept spinning, which means that the click, which is a little device that locks into the gear, wasn't catching. And I just want to identify and name some of the parts now because I'll be referring to them a lot. I'll try to show this as clearly as I can. But first you have the anchor, which is right here. And connected to the anchor is the anchor pin, which goes up through the fork. And as the pendulum turns, it makes this fork go back and forth, move back and forth, which makes the anchor move back and forth. And that, in turn, makes the escape wheel rotate one tooth at a time. And it's the turning of the escape wheel that makes the hands go. And what's happening that I'm finding is that the motion of the fork, it's not going far enough to the left and to the right to get the anchor to move the escape wheel far enough for it to click to the next tooth. And I really don't know why that is yet. The other issue with trying to wind the clock is the part that you hear that makes the clicking sound when you wind these clocks, it's called the click. And it's not engaging what's referred to as the ratchet wheel. Hard to see in there, but you can see it turning. And the teeth are on that, and the click kind of fits in there to stop it each time you wind the key a certain amount, it doesn't unwind. And there's a click spring that controls it. And on this particular clock, it's actually a spring, like a miniature spring you would see in a pen. Normally these springs is just a strip of metal that's bent in half. I have never seen that before. To fix that, I have to take the clock completely apart to get that adjusted. As far as figuring out why the anchor is not going far enough to the left and to the right, I have to determine and check to see if the clock is in beat. And I also have to see if I need to replace the suspension spring, which I most likely will. However, once the clock is put into beat, and I'll explain later how that works, it should work even if only for a few minutes until you get the proper spring in it. So let me get to work on that. What I think I'm going to have to do is just take the clock apart, especially because I can't wind it, and there is a possibility that it won't work without any power being generated from a spring. I'm pretty much going to try to explain each step that I do. I may not show the entire procedure because it just will take too long. For example, the first thing I want to do is remove the pendulum, and this piece here is what they're calling a pendulum guard, and I can't slip it out from the bottom block until I remove this. So I'll undo that first. Just have to take out these couple of screws here. Once that's out, then I'll continue. The screws are out. I can lift up the pendulum and slip the spring out from the spring guard. And now I can slip this bottom block out from the pendulum. Okay. Next, I'll remove the suspension spring guard. There's a couple of tiny screws in here I have to loosen up, and this will slide right out. I've loosened the screws. This should slide out now. And I think you can see the suspension spring is bent, so it definitely needs to be replaced at some point. What I'm going to do next is remove the saddle, and I'm also going to start taking some photos of this so I have a good record of exactly how to put it back together. Before I get that out, however, I want to take out the screw that holds the whole suspension spring in position. Okay, I've loosened these screws. Okay, let me take a closer look now to see what I want to do next. So what I want to do next, I'm going to remove this back plate, which will expose all of the gears. Before I do that, though, I want to remove the whole clock from this base, just to have to undo these two nuts that are holding it in. And before I do that, I think it would just be interesting to see, now that I've removed the suspension spring, if it's the same length and positioning as in the book. So let's take a look at that. And I think it is. Let me try to hold this up. Hopefully we'll all see it here. I'm just putting it right over the 12E. And that's pretty much exact positioning for the top block, the fork, and the bottom block. And that's what I have to match when I put my new spring on. Anyway, let me work on removing the clock from the base and then undoing the back plate. The base is off. Now I'm going to undo the 4 screws holding this plate on. Once they're out, then I'll continue. I've removed the 4 screws. Let me zoom in a bit. And this is where it starts to get a bit tricky. The spring is hanging up. There we go. So next, I'm going to take some more photos of this arrangement before I proceed to take everything apart. I'll show how the gears come out of here. Let me zoom in a bit. One, two, now what I noticed that's interesting when I said that the click wasn't working, hopefully you can see the click right there. It's missing the ratchet wheel. It's kind of below it. That should be stuck into one of those little teeth. Anyway, let me try to remove this spring. Might be able to see that better. something's holding that on. So let me take a closer look. Try to remove the mainspring. Okay, I think I got it. I think I can slip this gear out of here too. There we go. And now, for sure, you can see how that click is not in the ratchet gear. It should be positioned lower. Like that. Now, if I continue taking this apart, I can remove these 3 pins, and that'll get this plate off, and it'll let me get the dial and the gears that control the hands off. But I don't think I have to do that. What I do want to do, though, is when I remove the ratchet here, I want to make sure it goes back in the right position. So I'll just mark it with a little red dot. That way I won't accidentally put it upside down. And next I'm going to just clean up the gears, although things do look rather clean, but especially the pivots and the holes in the plates that they go into as well. Once I've done that, I'm just going to reposition everything and see if I can wind it. I've cleaned everything up and there really wasn't much to clean. The gear pivots had little to no dirt on them at all. And the same with the holes in the plates, which are called bushings. And if you really want to clean the bushings well, you soak a toothpick in a bit of nail polish remover for the acetone and just insert it into each one, and you'll get the last little bit of dirt out that might be there. What I want to do next is try to position the spring. And I'm going to put the ratchet wheel onto the gear first, onto the spring first. By doing it that way, I was able to get the click to line up properly. So now I think when I turn the spring, you get the clicking sound. Okay, what I'm going to do now is look to reposition the rest of the gears. But before I do that, I want to lubricate the pivots and the bushings with some synthetic clock oil. And the way I do that is put a little bit of it in the well, and then using what's called a oil pin, a little bit, and just place it on the ends of the pivots as well as around each bushing. I'm going to do that with all the gears and bushings, and then I'll be ready to reassemble. I'm ready to reposition the gears, and I'll try to show it. This one fits under the mainspring. This goes here. This one here. That's the escape wheel. This goes here. And lastly, the anchor goes here. Whoop, there we go. What I have to do next is position the plate back over it and kind of tease all of these pivots into the bushings. And that'll take some time. I'll work on that and then I'll continue. I'll try to explain the technique that I use to get the plate back on properly. What I've done so far is I've just positioned it over the arbor of the mainspring. What I do next is I'm going to maneuver the pivots of the anchor and the escape wheel into the two bushings here. Once they're in, I'm going to position these two screws just a little bit, not too tight. And then as I work my way down, getting other pivots into the bushings, the fact that these screws are in here will prevent it from popping up as I'm manipulating the far end. And you just slowly and gradually work your way down. You can never force a pivot in. If it's tight, you have to loosen up the screw a little bit. The last thing you want to do is bend these. Anyway, let me get to work on it, and hopefully once everything is back in and the screws are in, then I can continue. It took some doing, but I was able to get everything back together. And let's see if I can wind it now. Very good. And let's see what happens when I try to move the anchor. Now it looks as if the escape wheel is working properly. That's the motion that it wasn't doing before, which means each time I move it, the hands move. Let's see if they are in fact moving. Not really sure of that yet, but let's put it back together and see what happens. And yes, I see the hands moving now. Very encouraging. So the first step will be to place the clock back onto the base. Let me work on that. I've got the clock back on the base. What I'm going to do next is reattach the suspension bracket, and keep in mind pretty much what I'm doing is just reversing all the steps I did in taking it apart. So I'm just going to position it, screw it in, and then continue from there rather than spending time having you watch me do all of that. Okay, what I want to do next is reattach the suspension spring. Now, even though I need a new one, I'm still going to put the old one on because the clock, if it's working properly, it should run at least for a few minutes with a twisted or bent spring, long enough to see that the hands are actually moving before it stops. So I want to make sure that it's actually working before I go to the trouble of putting a new spring on here. Now I'll hang the pendulum from the spring. And what I'm not going to do yet is reattach the suspension spring guard or the pendulum locking bracket. What I want to do instead is get this back onto my workbench and give it a spin with the pendulum, and let's see how long it runs for. Okay, it's set up, and the way you start these with the pendulum at a dead stop, you rotate it one complete revolution. And then just let it go. I'm going to push the hand back to 5 o'clock. And we'll give this a few minutes and see if it's actually running. It's been a few minutes, and as you can see, the clock is working. A couple of things that I am noticing is, one, it's running fast. And the way that you adjust that is there's a disc on the top of the pendulum that you can turn either to the left or to the right to make it go slower or faster. But before I get involved with that, I know it's going to need a new suspension spring and also to put the clock into beat. And what I do see that I like is how nicely the escape wheel is moving, and I'm going to try to show that. And I can tell that it's out of beat because as the pendulum turns, it has to turn a great distance for it to do one click. And then as soon as it goes the other direction, it clicks right away. and it really should be the same amount of time going each way. But it is running, and I think what I'm going to do before looking to do a new suspension spring, I'm just going to let it run as long as it possibly can, and whether it's an hour or overnight, we'll find out, but we'll see how long it actually goes before it stops. Well, as you can see, it didn't go that long at all, maybe 5 minutes at most, which I think was pretty much to be expected. What I'm going to do next is replace the suspension spring, and that's quite involved. I will take you through the steps on how to do that. I removed the suspension spring from the clock. I made a copy of the unit that I have to match, and this is the size that's required, the .0023. And I have one of the springs here. And the top block, fork, and bottom block, they're all held on by these very tiny screws. And I have to undo them to slide these pieces off, fit the new spring in, and cut it off at the proper length. And that'll take quite a while, so let me work on that. I've attached the parts to the spring, and when I move it over the copy, you'll see that they line up pretty much exactly where they have to be. So what I want to do next is I'm going to reattach the pendulum spring to the clock along with the locking bracket and the spring guard. And once that's completed, I'll be ready to put the clock into beat. Everything is back on, and I'll try to show it. Including the pendulum. And I'll explain what that piece of blue tape is for in just a moment. Now I have to put the clock into beat, and to do that you give the pendulum a turn to get it going, and as it's going around each direction it's going to cause the escape wheel to turn one tooth, and each time it moves you're going to hear a click, and you have to mark where this pendulum, where the blue tape is, where that happens to be when you hear the click, as it goes to the left, as it goes to the right. If you have good hearing you can actually hear the click. If not, and I do not, you can pick up something known as a beat amplifier, a device that magnifies the sound. And that's what I have, and I'm going to show you how it works. Turn it on. And just touching this magnifies the sound. Anyway, you give, to start the pendulum, 1 complete revolution. And then you let it go, and hopefully you'll hear the click along with me. And there's 1 click there, and another one pretty close to it. But when this clicks here, it stops here. You have to mark that spot next. Clicked here, stopped there, clicked there, and stopped here. And what's happening is the distance from where you hear the click to where it stops, that's the overswing. The overswing needs to be identical on both sides. Right now, when it goes to the right, the overswing is just maybe 1/4 of the dial, or if it was a circle. Going the other way though, you have the click, it's going almost 1 complete revolution. In this case, the overswing is too far going towards the right, which means you have to adjust the saddle here a little bit to the left. I have to loosen the screw and just turn it a little bit, and then reset everything and do this process again, and just keep repeating it until I get pretty close to identical clicking sounds and overswing. And at that point, the clock should be in beat and will continue to run. So let me work on that. I'm happy to say that I was able to put the clock into beat. I have it running. I have adjusted the pendulum to the proper speed, and it took quite a long time to reach this point. a lot of adjusting of the saddle. It turns out that these miniature clocks are a lot more sensitive than the traditional size ones. The slightest adjustment of it really dramatically changes how it's running. In fact, according to my Horolovar book, this particular clock, they actually refer to it as a midget clock. It's even smaller than what they consider miniature. But there you have it. It's the Kern and Sohn midget anniversary clock. It's from 1958. I hope you enjoyed the video. I hope you got a few good tips and ideas on what's needed to be done if you're trying to restore one of these yourself. And that pretty much wraps things up. Bye for now.